And it is Thursday, October 1st. This is algebra. We are going to go over day 2 of section 212. In class is numbers 15 and 16. Homework tonight is to finish off the review preview for the section, which is numbers 22 through 24. So if we start with number 15, those triangles that we were looking at yesterday, where we draw in that horizontal and vertical distance between 2 points, are called slope triangles. Slope is what we use to measure how steep a line is. And it's a ratio or a comparison of the vertical distance, that up and down value, to the horizontal distance, the sideways value. The vertical part is what we call the change in y. We've also referred to that as rise, and the horizontal distance we've called run. That's how, back in the olden days when I learned it, that's what it was referred to as. It's more appropriately referred to as the change in the y value. And instead of having to type out the change in the value, we just use this little symbol of a triangle, and that's referring to how much it's changing. Just like instead of writing out the words equal to or is equal to, we just use the equal sign. So for this, we have the change in x for our horizontal distance. So what we need to do is come up with, yep, didn't even put it in there. We want to write down the slope of these different pieces. So this one, the horizontal change, goes from 3 to 7. We said that was an increase of 4. Horizontal change goes from 0 to 1. Remember, we're paying attention to the value of the squares, not just how many squares there are. Here we had a horizontal change of 1, vertical change was 12. The change in the y values, 12 over 1. And this one was a vertical change in y of 1 over a horizontal change in x of 1. And then our last one was change in y was 27 over the change in x was 3, which we said simplified to 9. So what we're going to do is look at 2 points on a graph from here to here, and they have this slope triangle drawn in. And it says, what's the vertical distance for the slope triangle? Well, the vertical distance is 10. So the change in y is 10 over what's the horizontal distance? Horizontal distance goes from 0 to 10. So it's also 10. If we look at that on the actual resource page, or if you went to the online tools, it says draw smaller slope triangles for this that have a horizontal distance of 1 and figure out the slope. Well, change in y over change in x we already know is 1. If we do this correctly, it should also be 1. So I'm gonna make this into red. So if this is 5, then we must be going by ones for each square. So if I go over 1, I go up to the line, and it has also gone up 1. Over 1, up to the line, it went up 1. Over 1, up to the line, it's always going up 1, which happened to be our slope. So in this case, we use that change in y over change in x to find our slope. The equation for this line Again, we use y equals mx plus b. M is our slope or our growth. So our y value can be determined using 1 times the value of our x. And then what's the value of y when x is 0? It's 0. So again, this is one of those cases where if you want to put in plus 0, you can. But if you just want to leave it without the plus 0, that's okay, because anytime we add 0, we get nothing anyway. Moving on to number 16. What is the vertical distance for this triangle? So the vertical distance goes from 2 up till 4. So we have a change in y of 2. The horizontal distance starts at 0, goes over to 4. So we have a horizontal change of 4. So if we were going to do this using smaller slope triangles that only had a horizontal distance of 1, we would go over 1, and when we went up, we would only be going up 1/2. Over 1, up 1/2. Over 1, up 1/2. Over 1, up 1/2. Coincidentally, the change in our y value divided by the change in our x value happens to be equal to 1/2. Once again, we can write the equation of our line. Y is equal to the growth, or our slope, which is 1/2, times the x value, plus, in this case, we have a y-intercept of 2. Now let's double check that. Let's say I put in the number 2 for x. 1/2 times 2 is 1, plus 2. 1 plus 2 is equal to 3. And when x is 2, y is 3. So our equation worked. And I misspoke earlier, this is number 16. So we're going to use the line that we graphed over here with slope triangles of A, B, and C. So find the slope using each of those triangles for A and B. So for A, our slope is change in y is 6 over the change in x is 4. We get 6 over 4. For triangle B, we have a vertical change, or change in y is 3. And our horizontal change, our change in x is 2. And it happens to be that 6 divided by 4, when we reduce that, we get 3 over 2. It doesn't matter which slope triangle you use, you are going to get the same value either way. So in the next one, it says if we have a horizontal distance of 3, what will our vertical distance be? Well, I know that 3 divided by 2 is our slope. I want to know what that's equal to when my horizontal distance, my change in x, is equal to 3. So if you want to use the idea of a giant 1, what do you multiply 2 by to get 3? Multiply by 1.5. So we multiply the numerator by 1.5. 3 times 1.5 is 4.5. So this vertical distance should be 4.5 squares. 1, 2, 3, 4.5. Again, anytime that you are doing a slope triangle, the simplified ratios should always be equal. So if we want to draw a slope triangle with a horizontal distance of 1, I'll use purple, and 1 square happens to be equal to 1. So if I go over 1, I go up 1.5. 3/2 is equal to 1 1/2. Your slope on a single line is always going to be equal, regardless of the points you choose. Homework tonight is numbers 22 to 24. As always, if you have questions, log into the 2 o'clock meeting with your math teacher. Have a good night.